Well, the reductionist view, I would say, is based perhaps on two very important elements. One is the view that the world acts as a machine, as a deterministic system. If you know the initial condition, then you will know the outcome. I mean, the model would be very simple motions, pendulum, planetary motion, and so on. The second aspect, I would say, is to say that finally the complexity which we see around us can be reduced to simplicity when we go sufficiently deep into the description. Like Feynman once said, the world would be like an immense game of chess, which looks very complex when you see it from the outside. But once you know the rules and you see that each rule taken separately would be very simple. And I think this kind of vision of the world is now put into question. They would even go further and say it has proved to have its limits. My role as a physicist is not to invent the universe, but to describe it. And I think that this universe which we describe now is more what we see around. And in addition, I think it leads to less alienation. It leads to less alienation because we are then closer to the universe which we describe. I can remind you the work of Jacques Monod, one of the great French molecular biologists. And he thought that physics is dealing with deterministic systems, but life is an evolutionary process. How to reconcile it? Then he said, well, life is tolerated by physics. It's not really part of physics. It's a margin of physics. And man, of course, is at the margin of the margin. Therefore, as he said, the man is like a gypsy. It's the outskirt of nature. Now, I think this is basically not so. On the contrary, if you understand that the laws of nature have this nonlinearity, have this, I would say, creativity, we can even say, then, in a sense, humans realize some of the basic aspects of nature. And therefore, it's no more an alienation, but on the contrary, the feeling that we are perhaps more part of nature than any other living being or any other object of which we have some knowledge. This problem, the problem of time, irreversibility, was really a problem which has always fascinated me. Perhaps this comes from the fact that as a young man, I was very interested in literature, art, and music, archaeology. And so I was to some extent perhaps astonished by the lack of interest for the problem of time in the so-called hard sciences. I would say that even not only there was a lack of interest, but there was even a kind of defensive attitude. It seemed that the triumph of science was that it had eliminated time. And I just could not believe in that, because after all, the time is really our main existential experience. This nostalgia for a timeless universe appears at many places in the book of Hawking. For example, at some point, he says, well, to understand time, we have to replace real time by imaginary time. Now, what does it mean? This means that in the real fundamental theory, there should be no difference between time and space. I shall not go into technical details, but that is what this essentially means. And that in some way, time has appeared through this breaking of this geometrical symmetry at the beginning of the universe as a kind of fluctuation. Now, it is a strange thing to have this fluctuation going on for 15 billion years. That's one thing. And then the other thing is, again, that I would say by trying to eliminate time, we come to a very difficult position, because then how to understand evolution, how to understand our own human evolution. When my book appeared in America, Heinz Pagels, a cosmologist, wrote a terrible review saying that this shows that Prigogine and his school are situated somewhere close to Maharishi. In fact, the title of his review was, "Is irreversibility a fundamental property of nature?" And his answer, no. And my answer, yes. And that is really the question which will be decided in the future. But I would say, since my book has appeared, much progress has been made. And I think we can safely, say it now, that irreversibility has to be put somewhere as a basis of dynamical description. And I'm far from being the only one. I would like to quote here Sir James Lighthill, who has written a few years ago that he, as a president at this time of the International Union of Pure and Applied Mechanics, wrote that he has to apologize in the name of his colleagues for having propagated for 3 centuries the idea that Newtonian systems are deterministic, idea which is proved now to be wrong. Now, I find this remarkable because, in a sense, everybody of us has to apologize from time to time for some mistake he has committed. But to apologize for 3 centuries for what was really the central point of what was called scientific philosophy, that is quite something. We see a lot of connections. We see many unexpected things in this universe. And therefore, the best analogy, the best symbol would be a work of art, for example, a piece of music. Because if you take a piece of music, let's say some work of Bach, there are very strict rules. But at the same time, there's always something unpredictable. Even if you have heard the elements of the melody of the fugue, you are not expecting the modulations. There's always something new coming in. It is very much like a symbol of the unstable world in which we are. There are laws, of course, but there are instabilities, bifurcations. Music or sculpture is also a symbol of this time because it is, after all, a time-oriented art. Music, that's obvious. That's an organization of the time. But even sculpture, let's not forget that the beginning, probably the origin of sculpture, is to a large extent funerary sculpture. It is to speak about life after death. It is to speak about ancestors, about our relation with the gods. In a sense, you can say that sculpture is made of stone into which we incorporate a temporal signal. It is essentially like we would put time into matter. And I think this is something quite general. In fact, non-equilibrium chemistry, production of biomolecules, that's exactly that. In a sense, it is temporalization of matter. Science should not lead to alienation. Science should emphasize our embedding in nature. And that is, I think, the direction in which it's going.